All right, so this is 3.2b, and we are down to example number 4. And one of the things that we learned from the last section, 3.1, that every ordered pair can be represented graphically as a point. So let me put that on here. Okay, so there's my graph. So what that means is every ordered pair, 3, 1, negative 4, 6, etc. These are ordered pairs. Every ordered pair can be shown graphically. There's 3, 1. Negative 4, 6 is right there. Okay? So every ordered pair can be shown graphically on this XY axis. And what we're looking for is we're looking for a pattern. And what that pattern is hopefully the pattern is if we connect all of the dots, we get a straight line. That's the ideal pattern that we're looking for. So, in this section, what we're going to do is we're going to graph linear equations. All right, so for example, if I have x plus y equals 5, and let's say I want to graph that, okay? Well, I can't list all of the ordered pairs because there's an infinite number. But you have to list a minimum of 3. You have to have at least 3. That's very, very important because let's say that you're trying to see if this is a straight line and you decide, I'm just going to graph 1 point. Well, can I draw a straight line? Yeah, I can, but I don't know where that line is. I mean, all of these go through that 1 point. So then you're thinking, well, I could draw 2 points. Well, then I've got 1 point or one straight line there. Shortest distance between 2 points is a straight line. Okay, so there's my straight line, and I think I'm good. But what if I drew the line? What if I found this point here and that's actually not where the point is? Let's say the point is actually here. Well, as long as I have 2 points, I think I'm good to go. So what I suggest is drawing 3 points. Because if you draw 1 point here, 1 point here, and 1 point here, and you connect the dots, you get a straight line through all 3 points. But let's say that that third point is over here. Well, and I drew a straight line through these 2 points. Well, I can't because there's a third point here. And if you have to get a straight line and this doesn't go through the line, then one of these 3 points is wrong. So by putting a third point, if a third point is not on the line, you know that you did something wrong somewhere. So that's the reason for that third point. And hopefully that makes sense what I just went over. Okay, so x plus y, let me get rid of a bunch of this stuff here. X plus y equals 5. So what I'm looking for here is the numbers that are going to make that a true statement. So what happens if I put in, whoops, what am I doing? X and y. Alright, so there's my table. So let's say I put in 0 for x. In order for 0 plus y to equal 5, y has to equal 5, right? Because 0 plus 5 is 5. What if I put a 6 in? 6 plus what is 5? 6 plus negative 1. 6 minus 1 is 5. What if I decide to put in negative 3? Negative 3 plus y equals 5. What number makes that a true statement? 8. Negative 3 plus 8 is 5. Now I can graph those 3 points. And ignore the black ones I have there. 0, 5. We'll do these in blue. 6, negative 1. And negative 3, 8. Now notice when you draw a line now, they connect all of them. So I know I did everything right because my line is a straight line that goes through all 3 of those points. Life is good again. Okay, so that's what we're doing when it says graph the solution set. We will learn many ways of graphing solution sets, but this way is the quickest and easiest at this point, making a little table there and figuring out which ones work so that we can graph those. Okay, the only problem with this method is that sometimes when you have more complicated equations, this method does not work until we do a couple other things first. All right, and that's what we're going to get into right now. Let's say that I have an equation. Let me get rid of my dots here. And let's say my equation is y equals 3x minus 1. Okay, this one's not too bad. I can still make my table here, and this is example 5. And I can just put numbers in here. It doesn't matter what numbers I put here for x. I usually try to get a positive number, a small positive number, so I don't get 37 for an answer and have to try graphing 37. I like this because this graph is just 1 to 8. So I try to keep my answers within this box here. All right, so 2, I usually try to pick 0 because 0 always seems to be a simpler answer, a simpler way to solve this. And then I try to pick a negative. Okay, so let's try 2 for x. Y equals 3 times 2 minus 1. All right, so that's going to be 6 minus 1 equals 5. So when I put in a 2, I get a 5. When I put in a 0, what do I get? 3 times 0 minus 1 equals 3 times 0 is 0, negative 1. And let's try negative 2. 3 times negative 2 is negative 6 minus 1 equals negative 7. Okay? So there's my 3 points I'm going to graph, see if I get a straight line. Well, and it just asked me to graph them. It didn't say only if they're a straight line. So, and negative 2, negative 7. Okay, so when I graph them, there's my 3 points, and there's my kind of straight line that's supposed to go through all 3 of my points. Okay, squiggly line that goes through all my 3 points. Okay, so there is the graph of this equation. So again, the points here are just reference points in order to draw the straight line. Every single point along this straight line, if we took the x value and the y value, like right here, if we, I don't know exactly where this crosses different places, but if we took this point and plugged the x value, the distance from here to here, in for x, and the distance from here to here, that's my y, plug them in, that would be a true statement. This 3 times whatever x is minus 1 would equal whatever this distance is for y here. Okay? So this ends up being some really cool stuff. I know it's math and I'm a geek, but I mean, this is the kind of stuff you use that you may not even realize when you're building something like a house or something. I use this kind of stuff all the time when I built my couple cabins that I built, and there's some real good geometry and trigonometry and math skills that you learn from learning how to do this graphing. Now, a lot of people that do construction have no idea that they use math to do it because they just kind of figured it out in their head, but it is all mathematical. All right, so example 7 says y equals 1/2 x. Again, draw our little table, put any number you want in here. What I usually do when I'm doing fractions, and it doesn't have to, it just makes your life easier. If this is a 2, or whatever this denominator is, always put in for x a multiple of this. So what is a multiple of 2? Well, 4, 6, 8, 10, something that 2 goes into. And that makes it easier. So let's say I put 3. 3 is not a multiple of 2. So what do I get for an answer? A yucky fraction. But let's say I put in a multiple of x. Let's say I put in 6. 1/2 times 6 is 6 over 2, which equals 3. That is a lot better number, no fractions. So that keeps you from having fractions. Okay, let's put in 0. 0 times 1/2 is 0. And let's put in another multiple, but let's do it negative. Negative 4 over 2 is negative 2. Then I can graph, and negative 4, negative 2. And I get a straight line there. Okay, I am going to go pick my wife up across the lake, so I'm going to stop here and start with 3.2c later on today.